Right, hello everybody. Welcome to our second collab session of this module. I hope you're all beginning to find your way around how the module works, how the learning units work. I hope you all are finding your ICE tasks. If anybody still can't find their ICE tasks, please just let me know. I have put links to the ICE tasks in the More Resources folder as well. So if you can't find them in the learning materials, you should find links to them in the More Resources folder. So there's no due date yet for the ICE tasks, but as I said, please try and keep up to date with them as you finish a learning unit so that you can submit them and I can give you feedback. There's quite a lot of people who've already submitted the first ICE task. As of yesterday, I think I marked all the ones that had been submitted and given feedback. So try to keep up to date. Otherwise, towards the middle of May, things get a bit hectic with another assignment due in early June and prep for exams. So the aim of the ICE task is really to check that you understand the material. And if you're submitting them too far down the line, it actually loses its impact and your feedback is not timeous enough. So please carry on submitting the ICE tasks. You all should have done the ICE task now for the first learning unit. So for those who haven't done it, please can you submit it? And I hope you all saw that the date of the assignment has been extended, which is fantastic for us, for you and for me. So the new due date is at the end of April. So we've still got lots of time. If you have already submitted your assignment, I see one or two students have, you can resubmit assignments right up to the closing time, and I have to mark the last assignment you submitted. So if any time you submit a bit too early and you want to make changes, then you just resubmit it. You can submit the assignment as many times as you want, but I can only mark the final one that you submit. So for anyone who has submitted a bit too early, you are welcome to resubmit at a later stage. And again, the national support session, we will hold it a week before the assignment is due. And that national support session basically will go through the assignment and make sure you understand the questions and how to answer the questions. It doesn't give any answers, but it gives you some guidance and it might cover something that you've missed. So it's not advisable to submit too early, rather wait and get it all correct and technically correct and submit it closer to the due date. So I hope that answers any questions about the assignment, but really glad it's been extended. So before we move on, has anyone got any questions that aren't associated to the learning unit? If you want to pop them up in the chat, you're more than welcome, and I can try to answer them for you. I do apologize for a lot of you that still have that other module on your VC Learn, the 122 module. And thank you for the one or two students who did join my collab session who weren't supposed to be there. Thank you for making the effort. That was really appreciated. But just ignore that module until it's removed from your platform. So you are all doing PSYC 1A, not PSYC 1B. Yes, Emily, it's perfectly acceptable to submit the ICE task within the next 2 or 3 days. As I said, there's no due date specifically for the ICE tasks. We need to get them in and submitted before the CAS mark is calculated because it forms part of your CAS mark. And your CAS mark tells us whether you have the correct mark to write the exam. So about the middle of May will all 4 ICE tasks be due. So there's no due date yet. I will give you the due date as soon as I know when the CAS mark needs to be calculated. But just keep going, keep progressing, and work your way through them so you're not stuck with them all at the end. All right, so let's move on to this learning unit. This is learning unit 2, and it's chapter 2 in your textbook, and it's on research methods in psychology. And this module has not actually been done in previous years, so I'm really glad with this new material they've added it in because research is a fundamental component of psychology. So it's not a scary module, it's quite a straightforward module, but it's really important that you understand it because everything we do in psychology is based on research. It's based on the fact that psychology is a science. As we discussed in the first learning unit, that psychology does form a science. It is empirical. Things need to be measured and tested and proved, and behavior altered based on our research. So it's an important module, and hopefully it'll give you a lot more insight into working through the further modules. So let's get started. So why do we need research in psychology? As we said, psychology is a science, and investigation is what psychology is about investigating questions. So we are committed as psychologists to addressing questions about behavior, and we do that through observation. It can be experimental, it can be just observation, but it's about addressing problems around behavior and gathering information to try and solve them. So as scientists, psychologists have to figure out, sorry, I'll get to that just now, how to make observations that will shed light on the puzzles they want to solve. Everything we do in psychology is about solving a problem. And we try and have to figure out how to solve that problem. And the way we do it has to be in a way that stands up to critical scrutiny of our peers. Okay, is there anybody else who can't hear anything? Is it just Bridget's? If you can hear me, give me a thumbs up. Okay, great. Bridget, maybe just check your settings. And to answer Taryn's question, basically when I do the collab sessions, you should have covered the material for the learning unit. So in the collab session, I present the material and hopefully it addresses any questions you might have. All right, so how do we do that as psychologists? We have a big toolbox of research methods because there's different ways of investigating things, different strategies of doing our research, and we'll cover some of those in this learning unit. And it's really important we understand research methods because all research methods are different. And in order to understand the information we look at in psychology, understanding how it's researched and how the results are presented will help you understand the information. So when you look at your textbook, every paragraph of your textbook has got some kind of research or information in it that has been part of a research project, and it's been investigated and results have been drawn, and that's what makes up the textbook. If you look at the end of the textbook, it's full of sources of information. And this isn't information that people have just pulled from the air. It's information that has been scientifically and empirically looked at. So it's really important to be familiar with the logic of what that means. What does research mean? And by looking at that, it will help us think critically about people's behavior and about claims people make. Because people can make claims about behavior, but has it been empirically studied and addressed and results given? So the kind of question in psychology, like a research question, it could be, I put on the left there, is, does an authoritarian parenting style impact on academic performance of children in primary school? That could be a typical research question that somebody might address in order to look at children who are misbehaving and say, well, are they misbehaving as a result of a parenting style? I need to research that. I need to look at the evidence, and then I need to answer the question. So research is about the questions and looking into the questions and trying to answer them. So why is it important to think critically? Because by thinking critically, it helps us answer when we look at something, what am I being asked to believe or accept? It's really important that we can look at something and say, well, is this believable or not? Or should I just accept it blindly? We need to be able to think critically about it and what evidence supports it. Evidence is really important. And are there other ways that evidence could be interpreted? What other evidence would I need to look at alternatives? And what are the most reasonable conclusions? We see that nowadays in the media, so much is presented to us in so many different forms that our ability to think critically and to say, well, do I accept this or not? And what else would I need to add to this in order to support my belief or my position? So it's really important that science is objective. It studies things objectively, not subjectively. Objective is about empiricism. It's about measuring and looking at all the facts. And one of the things in psychology is about bias, and it's about the way we think. And when we look at the world around us and we think about things all the time. There are so many things that influence how we think or believe something. So, for example, a confirmation bias is we look at something in the news or in front of us, or we're reading something, and we tend to notice and remember things that support how we think about it. We tend to not look at things that don't support it. We push them to one side. So we look at ways of confirming our own beliefs by looking at things that support us rather than contradict us. There's an overconfidence bias where many of us often believe we know more than we do. And unless we actually test it, we're not going to know the true answer. Hindsight bias. You could be looking at a research study and go, I knew it all along. You've got that bias of believing that you are right. And that is just supporting you, but you actually need to test it. So how we think about things actually does affect the outcome. So it's really important we think critically and we're aware of our thinking and aware of our biases. Yes, a conspiracy theory is a type of confirmation bias. If you have, in light of everything, COVID is a prime example in vaccinations. And, if you are somebody who doesn't believe in vaccinations, you'll look at all of those conspiracy theories that support you in what you say. You won't look at anything that contradicts you. So any kind of theory that supports you is a confirmation bias, and we tend to ignore those things that contradict us. So that is a good example of what a confirmation bias could be. So psychology is the science, we've said that. And our goals of psychology are to describe things, describe what happens, to be able to explain, explain, predict, and modify. So we we share those goals as with other sciences. It's about measuring and describing something. It's about understanding and predicting something, and it's about being able to apply and control something. So the first goal is measurement and description, and that's to develop techniques or measurement techniques that enable us to describe something. We can't just describe something out of thin air. We need to be able to understand what we are describing and how we measure it. So, for example, in studying the effectiveness of muscle relaxation techniques in reducing anxiety, a psychologist must first develop a means of measuring anxiety. Anxiety is something that happens. It's one of our variables in that particular instance, but how do we measure it? And in order to be able to describe it, we need to have a tool that can define it and measure it. So that's very important, is being able to measure and describe something. And then to understand and predict, that's our next step. So in order to do that, we make things called hypotheses. And I think you'll read a lot about hypotheses in psychology. And a hypothesis is a tentative statement about a relationship. That is our hypothesis. We've got two variables, X and Y, and we have to make a statement about their relationship. So, for example, muscle relaxation techniques are not effective in reducing anxiety. That's our hypothesis. It's a tentative statement about a relationship, and then we have to go ahead and prove it or disprove it. It can work either way. So if we've got two variables, X and Y, and we take X as our muscle relaxant, are we able to predict the anxiety, or does X cause Y? So that's what a hypothesis is. And all psychologists, when they're going into research, will start with a hypothesis. It's a tentative statement, and the goal of research is to either prove or disprove that hypothesis. Our variables that exist, okay, are those things that we measure. They're the events or characteristics of behavior that are controlled in a study. So our variables in the case that was given, or the example, our variable is muscle relaxant techniques. That's our one variable. And our other variable is anxiety, two variables. That's what actually we're going to use to test and measure in our hypothesis. And ultimately, the application and control. It's why are we doing this? We're doing it because we attempt to apply our research findings to practical problems. We don't just do research for the sake of doing research. Research is done to address a gap in knowledge, to solve a problem. It's done for specific purposes. And that's where we look at our outcomes and work out how we're going to use them. So our hypothesis is our statement about a relationship between variables. Variables are the two things in most instances that we want to control or observe in order to apply and control behaviors or find solutions to problems. So for example, the more hours you spend on social media, the lower your exam mark will be in your final psychology exam. That's our hypothesis. That's what we want to test. So we decide that our variables there would be the hours spent on social media and our exam mark. Does X cause Y? Can we predict Y from X? I hope that that's clear. It's just a very basic, simple understanding. And at this point, this is all we need. So psychology is a science. It builds towards a better understanding of behavior. That's what it does. And psychologists construct theories. And we've done theories. In the first learning unit, we looked at a number of theories and theorists over the evolution of psychology. And that's what they've all done. They've developed theories. And a theory is a system of ideas that they put together to explain a set of observations. But the main thing is a scientific theory, which is what these are, has to be testable. It's not random. It's not brought from a place with an answer that we can't support. We've got to be able to test our theory, and we've got to be able to support our theory. So theory construction basically is you construct a theory and you build it up, and you can revise your theory till you get to a point where your theory is complete. Okay, but no theory is ever sort of complete. It can be redone and things reapplied to it, so it can be built on. And often you'll see theorists build on someone else's theory as a foundation, and they build on it. So it's iterative, and it can always be subject to revision. And research methods are a most important part of the social sciences, as they explain how intellectual functioning can be enriched. And using a scientific method. So psychology is a science. The scientific method is to make observations. That's what we do. In order to collect data, that's what we do in order to improve the quality of human lives. So that is why psychology is a science, and that is how research works within the science. So with anything, any kind of problem or process, there are steps to scientific investigation. So if we say the hypothesis is, for example, students who study over a span of 3 weeks before a test perform better than those who wait the night before. So it would be, how do we actually go ahead and test that? The first thing we do is we develop a problem statement. What is the problem we're trying to address? It might be students spend too much time on social media and their marks are dropping. Therefore, we need to investigate it. That could be the problem we're trying to solve. We then look at developing our research question that we're going to ask. We develop a hypothesis. We design our research. We collect our data. We look at our data and we analyze it and we report results. And that's the process of scientific investigation. And that applies across all scientific disciplines, is that science is a series of steps towards actually solving a problem. So steps in the investigation, firstly, a problem statement. Okay, it's usually if somebody has a research paper that you read, and you'll read a lot of research papers, right in the beginning, it will present the problem. Why is this study being done? It must have a reason that it's being done. As I said, a gap in literature, or a new phenomenon that's evolved, or something, but there must be a problem. And why is that problem worthy of investigation? How can what I do or add to the research body advance knowledge? So, you know, you have to do it for a reason, and it has to be worthy of doing that. We develop our research question. What is the question we're trying to answer? A question that can be answered through the collection of evidence. It's succinct, and it's the focus of the purpose of the study. So the question could be, does time spent studying increase achievement? That's the question we're trying to answer. So the step is develop a research question. The next step is the hypothesis development. And we spoke that hypothesis is about a relationship between variables. So a good hypothesis can be tested. So educated, testable prediction about what will happen. And the researcher needs to prove or disprove the hypothesis. And variables must be given, like we said, with their definitions. Okay, so your variable could be your amount of time studying, and your other variable could be exam marks. So students who study 5 hours before an exam versus students who study 3 weeks before the exam, that's the variable, and the other variable will be the marks. Verna, I don't think there's something wrong with the slides. If anyone else sees a problem, please just let me know. Your research design is your next step. How am I going to do this? What am I going to do? How am I going to collect this evidence? What process am I going to use of collecting information? I have to develop that. And you do all of this before you start the study. You draw all of this up. This is your research plan, and you do it before you study anything. Is all of this needs to be thought about and listed. How am I going to collect the data? Do I collect it from a sample? How much data do I collect? So in this case, the data could be collecting academic marks, doing study method questionnaires, people doing self-reports of time management. How am I going to collect that information I need? Once I've collected that information, how do I analyze it? So now I'm sitting with a whole pile of completed questionnaires and observations or interviews, and how do I do that analysis? Your research design can change. It's iterative, as we said, is that if you believe that you put a research design together and you see that it's not worked, then you'd have to go back to the beginning again and start again and look at a new research design. So the whole process of research is iterative. Okay, that's what it means. It's going back and doing something again. So once you've analyzed the data, the final thing you do is your report on the results. And that's the biggest part of your research that you read generally, is people discussing those results. You discuss it in terms of what other people have studied. You look at other literature. You compare it to what other researchers have found. You also discuss limitations, because it's honest, and it's saying that if I did the study, I recognize there's limitations to what I did. You can make recommendations after you get your results. You can recommend other studies that might need to take place. So that's all part of your reporting, and eventually you peer review it and you publish it. So there are multiple published journals of research papers. If you put anything into your EBSCO host, you will draw a host of research reports, research articles. And as undergrad students, you'll just build gently on this process until it gets to a final point where you will be doing your own research. And it will be maybe in your honors, you'll have to do a research project, and again in your master's, a research project. So it's really important to understand, because this is what you're building towards, but it also helps you interpret what you read, because when you do your assignments, you guys have got to read research, and understanding what research is and how the data was gathered will give you a better interpretation of what you're looking at. So that is how the steps in a scientific investigation work. Those different steps, which you start as a plan, and then eventually you'll work your way through them. So the advantages of a scientific approach, obviously it's about clarity and about insight and a precision. Really important. It's precise. And when we read something and we know the research has been done, we can look at the results and we can understand them. They're precise and they're clear. And also, in research, there's also relative intolerance of error. So it means that we have to be thorough. We have to look at something, and if you're submitting a research paper, whoever reviews it is going to demand that the data is objective and the documentation is thorough. So there's very little room left for error after it's moved through its different stages. So that's the process of research. So in this module, what we do is we look at 2 types of research approaches. There's quantitative research and qualitative research. Okay, 2 different words, 2 different ways of approaching research, and ultimately it depends on what you want to study. So qualitative research, okay, think about quality. whereas quantitative is more numerical and numbers based. So qualitative research, this approach, and if you look at the picture, there's two people sitting in an interview desk. So something there about a conversation, about an interview. They're not completing a survey form. It's actually about observing and about listening. So that approach is used to understand mainly and interpret social interactions. And being qualitative research, if you had to take a sample, because you can't do your research on the whole population. So generally what we do is we extract a sample of the population. Depending on what it is, then that will guide your sample size. Obviously, small sample sizes, if it's something major, would have a problem, tend to choose a bigger sample size. But if you're doing something around interviews or surveys, you tend to use smaller sample sizes and generalize your results from there. So things like interviews with open-ended questions, taking notes in the field through observation. It's very subjective, okay? And it gives deeper knowledge. We have a chance to dig deep with our qualitative research, ask questions, dig deeper, extract information. It's provides a more subjective opportunity to dig deeper into the subject matter. Whereas our quantitative research, that's more numerical based around quantities. So we aim to test hypotheses, look at cause and effect relationships, as well as make predictions. And that can use larger sample sizes, and that's based on numbers that involve statistical analysis, and it's also pretty objective. So two types of research, and we'll just look at both now after this slide. So I hope that's clear. It's quantitative and qualitative. So quantitative research, okay, this is the one that is sort of numbers based, okay. We look at things like using experimental and control groups, where we have two groups of people, where one receives a treatment and one doesn't. And then we compare how the experimental group did compared to the control group, and can we identify any outcomes that we can then broaden to the wider population. So experimental research design, and you read quite a bit about experimental research design, it's where your variables, your independent and your dependent variables, can be manipulated or held constant. And the goal of experimental research design is to establish cause and effect. So if we discussed a variable, we have two types of variables, and we'll keep on talking about these. So it might seem a little bit hard now, but you will come to understand it in a few later slides where we have a few examples. The independent variable is a condition or event manipulated by the experimenter. So if we look at our social media, and the amount of time on social media impacts your marks in your final psychology exam, the experimenter can manipulate the number of hours. He could take someone's devices away and say, well, you spend 2 hours, you spend 3 hours. He can manipulate that. That's the independent variable. The dependent variable is the aspect of behavior thought to be affected by the independent variable. So that would be the marks in the final psychology exam. So your dependent variable depends on your independent variable, and we can manipulate that independent variable. We also have a few things that creep in sideways called extraneous variables. And when we look at an experiment like this, there can be other things that do compete with that independent variable. So for example, we can manipulate the hours, but maybe the study environment is wrong. Maybe it's a room on a very noisy road, that no matter how much you manipulate the number of hours, there are other distractions that might take place. So those are extraneous variables that compete with the independent variable. And to some extent, the researcher should try and identify what they could be upfront and to try and control them. But all of the research that we read talks about dependent and independent variables. But nothing can ever be perfect, okay? And whatever we do in research, there's threats to it. It can never be completely pure or completely precise. We can try as hard as we can, but we do have threats. So we have things called threats to the internal validity. So picture the experiment and picture it in a bubble, and it's what happens inside that bubble with our sample that we've got in our bubble and our independent variables and dependent variables. There can be threats, and the researcher again should try to identify them. So things like selection bias. Who have we chosen to be part of this sample? Okay, if we've chosen incorrectly and we've chosen the wrong sample from our population, it's going to impact on the outcome of our study. So say we wanted to test the impact of a new diabetes medication on diabetes patients, and we choose people in the sample who aren't actually suffering from diabetes. It would be selection bias. We've chosen the wrong people. Mortality. If a psychological research project takes a long time, because you get some research that takes place over a number of years, you can get participants who maybe drop out of the experiment for one reason or another. Your numbers get reduced, so your sample size ends up smaller. That's called mortality, and that also impacts on the outcome of your research. The instrumentation threat is, what are you using to do your test? It could be the wrong instrument. It could be people have seen the instrument before. So you've just got to make very clear that what you're using is not going to be a threat to your outcome. History threat. Things happen while people are doing research studies. There could be something, an event or a phenomenon like COVID. I mean, imagine how COVID sent a number of research projects for a ball of chalk over these past few years. That things happen that actually could affect the project itself. Maturation threat. People get older, longer research projects, people get older, they mature, their perspectives change. Maturation threat. And testing threat. People become sensitized to questions. So if you have pre-test and post-tests, and your pre-test is very similar to your post-test, people could become sensitized to questions. So those are all things that impact on the outcome. And it's really important that as researchers, we recognize that before we start. We can't put those under the carpet. We have to understand them. As well as when we do our research, we take our sample, our little sample of people, and we say, okay, we've got the results for our sample. Therefore, now how do we apply that to the whole population? Okay, so that's a threat to external validity. So what happens outside our bubble, the external environment, and can we take those results and expand them to a larger population? Threats to external validity can include the wrong sample size. Like we said, maybe your sample size was too small. If you want to generalize to a big population, you need to have a decent sample size. It's no good doing the diabetes experiment with 2 people. You might need to do it more with 200 people in order to make sure you can generalize your results to the larger population, as well as multiple treatment effects. So other things could be going on with that particular person, and there could be other treatments going on, and that will also affect how you can generalize it to the larger population. So everything we do, it's like with our, again, revert to COVID, because I think it's still fresh in our minds. When they develop the vaccine, they start on a sample and they say, how effective is it on the sample, and can we generalize that to the larger population, and what would cause that to be a problem? So, Bridget, yeah, I mean, missing data could be a problem, as internal validity. Lack of context, again, is also important. So all of those things affect the validity of our results. So other design methods that you could use is quasi-experimental. That's where you go in knowing that there are other factors that can't be controlled. Therefore, it can't be a pure scientific experiment, because you know that there are other factors. You can control them to a point, but you can never actually rule them out completely. There can be descriptive research. There can be a survey asking large samples questions. There can be correlational research, which we'll speak about, which is about a design that's set up to look at the relationships between 2 variables and predict the future. And so that's best used when the independent variable can't be manipulated. So those are different types of design that we get in quantitative research, and we focus here on the experimental design. So if we look at this little concept check and we say which one in the statement is the dependent variable. Remember, the dependent variable will be dependent on what's happening with the independent variable. So a physiologist sets out to determine whether the calorific content of food, so that's whether it's high or low calorie, is a determinant of the amount eaten by rats who've been subject to food deprivation for 48 hours. which is the dependent variable. So the dependent variable is the one that the experimenter doesn't manipulate. In this instance, the physiologist would manipulate which food it gives the rats over the period of time and its calorific content. So that would be the independent variable, and the dependent variable will be the amount eaten by the rats. And again, with our experimental research, like we spoke about, an example is your experimental group and your control group. So testing morphine, for example, on the effectiveness of pain and the absence of pain. So the absence of pain would be the dependent variable, and the independent variable that can be manipulated is the amount of morphine given. So you would have an experimental group, for example, who receives the morphine in big doses or small doses, and a controlled group who doesn't receive the morphine. So the control group allows the researcher to isolate the effects of the independent variable, since they're alike in every way except other than what's happening with that independent variable. And therefore, you can say that the difference between those two groups is purely attributable to that independent variable of that shot of morphine. So that's how an experimental research designs, generally with an experimental group who the treatment happens to, and a control group who the treatment doesn't happen to. Okay, so qualitative research. Remember, this is quality, so it's working with smaller sample sizes. It's a bit more subjective, and generally it happens when it's something that an experiment can't be done for. So when we look at qualitative research methods, we've got things like interviews, case studies, looking at records, observing, focus groups. So observational research design, that's a kind of design for qualitative research. That's where we go and observe people in their natural settings. There's no observation. Maybe you want to look at something like bullying in the playground with children. You go quietly and you observe from a distance, and you observe interactions. You document, you write notes, you do a field study. Case study design is where you would have an individual or a group of people, and you go deep with them. It's an in-depth observation of individuals or groups, and you can collect a series of case studies in that way. But it does give you that opportunity to dig much deeper into your subject matter. And phenomenology design, that's basically saying it's experiencing a phenomenon when something happens and it's a phenomenon. So, for example, you want to study if a child is diagnosed with autism, for example, are the parents angry or are they sad? And you're taking the phenomenon of autism and you're doing a study around that. So your literature you review, your sample would be people within that phenomenon. So that's a type of qualitative research design. So there's different ways to design qualitative research. So on the left there is a table from your textbook. On the left-hand column is the quantitative. Remember, that's sort of numerical, data-driven. Things like standardized tests. We see that in intelligence tests. We see that in personality tests. Everything comes down to numbers and a result at the end. So it's quantitative. Our norm reference tests is where you confirm people how they are in a particular test to what the population is, and you look at differences. And questionnaires. Those are ways of gathering data. Qualitative methods, interviews with people, can be face-to-face, it can be over the telephone, it can be with a focus group. The interviews can be structured, i.e. I've got a set of questions I need to ask and get people's response, or it can be unstructured completely. I sit down with you and I have a conversation and I listen and I write, or semi-structured, sort of open-ended questions. So there's different ways to do that. Observation, like we said, there's observation completely in a naturalistic setting. There could be observation in a laboratory where you put a child in a laboratory with toys and you observe them in a laboratory setting. People go in and out, you observe their interactions, but it's quite controlled, but it's still observation. And just general participant observation where you immerse yourself as a participant in something specific. And qualitative can also be done through documents. We can retrieve documents, historical documents, archive documents, personal documents, and we can do a review of documents, and we can extract information out of those documents to make up our research. institutional documents. A lot of qualitative research can be around a literature review where you review other research that's been done in a particular area. So generally, it's just your data collection methods. So we either collect it directly from people or we collect it through secondary sources like documents, direct ways and indirect ways. And then we look at a meta-analysis, which is how we address previous research studies, because that's what we also do is when we do research, we have to look, is there anybody else who studied this? Have they got literature? And I need to include it, and we need to assess what other people have said. And are different ways of gathering that information. So that's an overview of the qualitative and quantitative data in your textbook. And if you struggle with that still, please let me know. So this, oh, sorry, I don't know what happened there. So this part is going a little bit more in statistics, and it's not scary statistics at all. It's just very easy statistics, but statistics form an important point of psychology and research. And why is because the statistics help us describe things. We can't describe things without using statistics, and it also helps us infer things. So descriptive statistics are procedures that we use to analyze the data. So we've collected all of our data. We've got all of our marks from our first year psychology exam, or I have a lecturer, I've got all of those marks. So how do I summarize? When IE asks me for a report on my students, I don't just say they did well. I look at the marks, I analyze the marks, I summarize, and I describe them in a meaningful way. Okay, so it's really important with statistics. Statistics help us describe the data. What are we looking at? We're not just looking at a huge, big spreadsheet full of numbers. We need to actually boil those down to a meaningful interpretation. So the way that descriptive statistics works, all the three kinds, is our central tendency, our variability, and our correlation. And don't worry, we're going to cover those shortly. So what statistics can describe data? If I've got a spreadsheet of numbers, measures of central tendency, and you all know this, it's very straightforward. It's basically your averages. So we've got a set of data. One way to describe it is to look at our mean, which is our average. You all know how to calculate the average of something. It could be through a median. So if we put everything in one long row from longest from smallest to biggest, what is the middle number? That could be our median. And the mode is the number that occurs most often. And generally, the point that most people use is the mean. So in your range of data, you work out what the average is, so you can see what the average of those results are. That's central tendencies. Very straightforward, and it's a way of describing the data that we have. Variability. So variability is the spread of data. So if we put the whole lot of data out in a big long line or in a graph, it's how much is that data spread out? And the mean is not always the true representative, because you can have outliers. You can have somebody who did really badly and somebody who did exceptionally well and got 100%. So the mean is sometimes not always the correct way, or it can be supported or added onto by looking at the variability. So the variability gives us the overall picture of the data. The range of the data is the difference between the highest and the lowest values, a simple measure of spread. And then your variance and standard deviation, and don't get panicky about this, because back in the day when I studied psychology, we were given a little book with all of these tables and charts, and we had to look up variance and standard deviation. Now there's computer programs that do it for you. So if it ever gets to a point where you do have to, in a research project, work it out, you enter your data and a little program like the one on the left will pull it up for you. And that basically tells us how values are spread from the mean. Okay, so your standard deviation of that is the most common, but don't stress about it. And if you struggle with these terms and concepts, there's some really great little videos on YouTube that help sort of demonstrate them and explain them. But all we're doing at the moment is we're saying that data needs to be described through things like the mean, how the data is separated from smallest to biggest, how far are people from the mean, and it's looking at all of those different things. So variance is calculated of each value in the data set from the mean. So how far is, if the mean is 50 and I scored 65, in theory I'm 15 15 points away from the mean. So you square all the differences and divide the sum of the squares by the number of the values. It's a simple little calculation, but your computer program will do it for you. And your standard deviation is the square root of the variance. So this is, I can get deeper into this, but it might be a bit complex. So if you've got any questions on this little way of describing statistics, please just pop me an email, and also use YouTube. There are some brilliant little simple videos that can help you with this. Correlation is the next thing, and you've probably done correlation or come across correlation before. And it basically, if we've got X and Y as our two variables, it tells us about the relationship. Is there a relationship between those two things? So between X and between Y, is there a relationship? That is our correlation. So it needs to be used on data that's quantifiable, so like academic scores rather than race or gender. So it's something you've got to score on, and you've got a score for Y and a score for X, and you put those two things on a graph. And a correlation can be positive. So the first picture is a positive correlation. What that means is as Y increases on your left axis, so X increases. The two things are related positively. As one increases, so does the other. So a positive example there is the more hours we spend studying, the better we do in our psychology exam. Those two things are positively correlated. As one increases, so does the other. That's all it's telling us, is there is a relationship there, and it's a positive relationship. It's not telling us about the relationship. It's not saying cause and effect. It's just purely telling us that there is a relationship, and it's positive. A negative correlation means that as something increases on the y-axis, the x-axis decreases, or the other way around. It's negative. So, for example, number of cigarettes smoked is a decrease in life expectancy. As the one thing increases, the more you smoke, the less your life expectancy is. There is a relationship, okay, and it's negative. As one thing increases, the other thing decreases. Positive, negative. And there are outcomes where there's no correlation at all. Statistically, there's nothing to relate these two variables together. So all correlation does, it tells us, is there a relationship? It's not at this point telling us cause and effect. It's not saying that Y causes X. It's just telling us that there is a relationship. So with your correlation, there's your positive, your negative, and your no correlation. So your correlation coefficient, it's called R. Okay, R is our correlation coefficient. That's just telling us that R number is telling us the strength of the relationship. And that can range between 1 and -1. That's where your R sits. It only sits between 1 and -1. So 1 is a perfect positive correlation. Okay, there's a relationship between those two things. They are perfectly positively correlated. -1 on the other end of the scale is there's a perfect negative correlation. So your positive numbers above naught is saying it's a positive correlation, and your negative numbers below naught are saying it's a negative correlation. And naught, when sitting right in the middle, it means there's no relationship at all. So that's our random scatter plot sitting there in the middle. So R tells us the strength of our correlation. Your correlation can be high, like really close to 1, okay, or like 0.9, or it can be low, 0.5. And the same with your negative. It can range from sort of any negative number up into -1. But it's just telling you whether there's a low correlation or a high correlation. So it gives us the ability to predict. So we can predict the ability of one variable based on another. So the relationship does say that if I smoke too much, my life expectancy will decrease. And those two results are correlated to 0.5, minus 0.5. It's just showing the strength of that correlation. Okay, so we know that they're related. We're not too sure how they're related, but we do know that there is a relationship. But, you know, with anything, again, all it's telling us is there's a relationship. There's a lovely study, and it says there's actual data collected that in the state of New York, when ice cream sales increase, the murder rate increases. That there's a positive correlation between ice cream sales and murder. Okay, it's data, it's real, it's a fact, but it's telling us that there is a relationship, but it's not telling us what that relationship is. Ice cream sales increase, and so do the number of drownings. The data tells us on the days that there are increased ice cream sales or the weeks there are increased drownings. But remember, it's only showing us a relationship. If you look at that and you say, okay, well, it's, maybe there's other things. A sunny day. When it's a sunny day, we go outside. We spend more time outdoors. We're more vulnerable to murder or homicide. When it's colder weather, we're inside. We're not more subjected to going out and being murdered. So, that could actually link to being a sunny day, that the ice cream sales increase because of sunny days, but also on sunny days, people go out more. Therefore, there's a higher probability of being murdered. And the same with drowning. On a sunny day, people swim more. Therefore, there's more higher probability of people drowning. So as much as we can see that there is a relationship between those two variables, and quite a strong relationship, that's all we know at that point completely. We know nothing more than that. So positive correlation, we said high scores on X are associated with high scores on Y, low scores on X associated with low scores on Y. Positively correlated number of cigarettes smoked, blood pressure increases. Less cigarettes smoked, blood pressure decreases. So that's a positive correlation. On sunny days, there are 3 times more ice cream sales. Yes, so if you plot sunny days against ice cream sales, you'll have a prediction, probably a better predictor than murder and ice cream sales. So you could plot the temperature and the ice cream sales, and then you could show that on sunny days, there's an increase in ice cream sales. Negative correlation is exactly amount of cocaine ingested, your number of hours you sleep decreases. The two things are related. There's a negative correlation. The more cocaine you ingest, the less hours you sleep. Okay, negative correlation. Inferential statistics. So we've had descriptive statistics. We've said, how do we describe all of this data that we've got in front of us, these spreadsheets and these numbers, how do we describe it? And after we've described it, we use it, okay? And inferential statistics is a way to interpret the data and draw conclusions. So now I've got this massive data. I've described it. I've got all my measurements and things. Is how can I use that data to predict and make inferences? And does it support the hypothesis? So that's what inferential statistics does. And data from a sample that we've drawn, we now say, okay, I need to apply this to the bigger population. So again, important the sample is selected correctly when we do it. And then what we do is we calculate, and you won't have to do this, but you might read it, okay, at this point, statistical significance. And it's like saying, we found all this information out. What is the significance of it? Is it due to chance? And that's the big thing in psychology. Have we put enough in place to make sure that it's not due to chance, that it's just pure luck that things have happened this way? So basically, you would calculate the statistical significance. Very low statistical significance is less than 5 chances in 10. Okay, so that tells us that the hypothesis we have put forward to test, that we want to test, a low statistical significance tells us there's a 5% chance that our hypothesis was wrong, because our hypothesis can be wrong. And we accept that as researchers. We're not trying to predict something, we're trying to test something, and maybe what we are testing is actually not correct. So right at the end of it, it will tell us that the information that we've got, that we've analyzed and that we've inferred is statistically significant. Okay, that it's very little chance that it's due to chance. Okay, so generally sort of a 5% statistical significance would tell us that our research is good research and it supports our hypothesis. And then from there, once we've got that, once we're happy that it's not due to chance, once we're happy, we can then generalize it to the larger population. Okay, so it's really important that people test for that to make sure that their results are not due to chance. Okay, so that was a bit on statistics. We're going to draw shortly to a close. So well done for hanging in this far. It's a lot of information. But again, it's once you just go through it and you help if you need it, it's quite easy to understand at this level. So ethics. Ethics is really important in psychology. And when anybody does research, research has to be ethical. Um, and generally, research that's submitted has to go through ethics committees. Most universities have ethics committees. Most institutions have ethics committees. And before any research can be done, you've got to check that it's ethical. Okay, and it has to be done before you do the study. You can't do the study and then you're called into question over the ethics of the research that you've done, and you're bound by regulated ethics, and it's there to protect people. We can't just go willy-nilly injecting people with diabetes medication without going through stringent ethical testing and legislation. And the Health Professions Council of South Africa and its Professional Board for Psychology say that psychologists are required to conduct for psychological practice and research and conduct it in accordance with legislative parameters. So it's really important. And there are guidelines, and it talks about things about voluntary participation, informed consent, confidentiality, etc., and deception. And it's really important. Deception is when you're not told the true purpose of the study in advance. You can't deceive people into taking part in a study. It has to be open and transparent, and people have to understand why they're part of this study. So ethics, common ethical guidelines. The rights and the well-beings of the participants is critical, and it's got to weigh against the study's value to science. So if the risk to the participants outweighs the value of that study to science, it's not an ethical study. If you're putting those participants at risk to study something scientific, participants have to make an informed choice about participation. It's their choice. It's not your choice. Generally, there are informed consent forms about participating in a study. Any deception must be justified. So, for example, if there's a control group and an experimental group and people don't know which group they are assigned to, but right at the beginning, they would say you could be part of experimental or control, but you're justifying as to why. Participants always, always, always have to have the right to withdraw from the study at any time. We can't hold them in a study. They have the right to withdraw, hence the mortality when we're doing the study. People might say, oh, I don't like this, I'm going. Participants must be protected from risk and also told the risks right up front. Investigators should debrief people, telling them the true nature of the study and what to expect, and all data must remain confidential. So those are common ethical guidelines. Yes, it would be. Have a look at it and see. Yes, that's a very interesting example, Leila. Thank you. Guys, maybe that could be a little research project. So again, APA ethical guidelines, and a lot of research in psychology back in the day used to be done on animals. And I think we saw that with our beginnings of behaviorism and things, is everybody, whether human or animal, should be treated with dignity. It's really important. And once we've done that, once we've got our research, we've generated, we've put it out there, and now you as a student have got lots of research in front of you. And again, how do we evaluate research? And we can't conclude, like we've said, that research is error-free. We've said there are errors that can creep in through the validity and through numerous ways. So another way to evaluate research is to do it again. Repeat the study, replicate it. And if the same thing can be done and the results are the same, then you're pretty much saying that it's quite a conclusive research study. There are biases, and we've spoken about that. It's an area that can change the measurement process. So we spoke about selection bias. Maybe people who aren't selected are not selected correctly. They're not representative of the population. When you choose your sample, you might under or over-represent some participants. If you're looking at something in an age and taking an age range, say I'm taking teenagers, you might select too many 13-year-olds and not enough 18-year-olds and not have enough true representation of the full teenage spectrum. Measurement bias could be an error in collecting data. The experimenter bias, the researcher themselves can be fallible. They could be open to the other biases we spoke about, seeing what they want to see. And the measure, what you're actually using, the measure itself could be not quite sensitive enough. And again, distortions in self-report, especially if doing questionnaires or interviews, just always remember, are people saying what they want you to hear? And that's always something that comes with research and interviews is, there's a social desirability bias. Are people saying what I want what they think I want them to hear. So all of that, when we evaluate research, don't always take it as perfect. Look at the different biases, and maybe there are errors in the study, and maybe as a future researcher, you go and correct some of those errors that have taken place. And that's just the placebo effect, which you don't really need to know. It's just the last section, and it's basically the placebo effect. It's like if you take the pill, it relates to the expectations in a treatment group, and you expect to get better. So I'm not really going to go into that. It's not really part of your learning outcomes for this, but it's just an interest. So yeah, guys, if you need to jump off, thank you. That is research in psychology. It's literally just a taste, but hopefully when you start to read further in your book, when you start to do your assignment, you'll see some of these words and some of these processes come into place. And if you've got any questions, please just ask me. Sorry if you've got to jump to journalism or English, still trying to figure it out. That's why I stick to psychology. Guys, thank you very much. I will stop the recording and I will upload the recording. And if you've got any questions, please just let me know. Thank you, everybody. Enjoy your evening. Don't forget your ask tasks, please.